The moon has become Earth's unseen power base far more than a distant rock. With invaluable ice at the South Pole, breakthrough sample returns, and emerging orbital networks, the next chapter of global influence is unfolding above us. In this video, we dive into 3 critical shifts: lunar resource potential, how the US and China are racing to build a lasting presence, and the rise of advanced orbital coordination. Stick around. You'll discover why the moon is now center stage in our shared future. The lunar South Pole holds a secret: water ice buried in permanently shadowed craters. That's not just frozen mist, it's potential fuel, oxygen, and life support for future explorers on site. In June 2024, China's Chang'e 6 mission brought back almost 2 kilograms of soil and rock from the moon's far side, an unprecedented scientific achievement. Artemis also includes the construction of the Lunar Gateway, an orbiting platform to support rotations, logistics, and scientific missions. However, scheduling adjustments and funding delays have sparked questions about long-term execution timelines. ILRS will integrate nuclear and solar power arrays, infrastructure for pipelines and crew rotation, and robotic systems to support sustained lunar presence. Following Chang'e 6's sample success, Chang'e 7 set for 2026 will scout for more polar ice, and Chang'e 8 arriving in 2028 will test technologies for in situ resource utilization, turning lunar soil into usable material. This pristine sample from the Apollo Basin in the South Pole-Aitken region helped scientists uncover volcanic history dating between 2.8 and 4.2 billion years ago. These coordinated actions enable inspection, alignment, and rapid repositioning akin to a dynamic formation supporting broader space objectives. This ensures critical systems, such as communication relays, scientific payloads, and orbital power sources, remain reliable and effective over time. It's less about rivalry and more about building a reusable, responsive space environment. China's advances reflect a shift from isolated spacecraft to interconnected systems, ready to underpin habitats, telescopes, and deep space missions. From Chang'e 6's far-side samples to the mid-2030s ILRS vision and China's coordinated satellite networks, we are witnessing the birth of lunar architecture. While Artemis offers global participation and symbolic leadership, China's phased, resource-driven strategy is constructing the groundwork that may endure. The question isn't just who lands first, it's who builds the systems that last and that define the rules of space. The moon isn't just a destination, it's the foundation of our future. Let's shape that future with intention. The project plans a powered base by the mid-2030s with rotating crews and sustainable energy systems, but that's just the start. More satellites are being networked for communication, navigation, and data relay with the capacity to perform coordinated maneuvers. In addition, China's recent outreach offering to share lunar samples with American universities like Brown and SUNY Stony Brook represents a symbolic level of scientific diplomacy, contrasting with the USS Volf Amendment, which limits formal NASA collaboration with China. That history isn't just fascinating, it informs our understanding of the moon's interior and helps guide future resource planning missions. The first to build a functional, sustainable lunar base will define scientific funding, rule setting, and public perception around the future of space. Building on that success, China and Russia are now advancing the International Lunar Research Station, ILRS, targeting initial construction between 2026 and 2035, with full operations by 2036. Whoever establishes on-site infrastructure first will shape scientific priorities, foster partnerships, and influence treaty interpretations. The South Pole's ice and constant sunlight in nearby peaks make it ideal for fuel production and energy generation. Why does this matter? A powered base enables long-term missions, telescopes, labs, in situ manufacturing, and human stays. So, this isn't just about flags, it's about transforming the moon into a launch pad for deeper space exploration, building a hub for science, and cementing Earth's future infrastructure. On Earth, competition is heating up, but on the moon, it's a blend of ambition and diplomacy. NASA's Artemis program aims to land astronauts by late 2025 or early 2026, backed by the Artemis Accords with over 50 participating nations. Meanwhile, China is executing a precise, phased lunar plan. Beyond that, China and Russia's ILRS now includes 17 partner countries and more than 50 research institutes. While Artemis leads in international unity and vision, China's methodical approach is producing tangible infrastructure and strategic coalitions. The moon's story doesn't end with landers, it extends to orbit, where coordinated satellite systems are becoming crucial to success. China has already deployed relay satellites like Kuiqiao to 2 support missions on the moon's far side. In 2024, analysts spotted Chinese satellites operating in groups of 5, executing synchronized orbital movements around a target's satellite. Meanwhile, platforms like Chang'e are being outfitted for robotic servicing, meaning satellites and equipment can be maintained, inspected, or upgraded in orbit. The result, a robust, flexible orbital architecture that can back up lunar surface operations, support deep space missions, and ensure resilience through redundancy. As lunar development accelerates, orbiting infrastructure must evolve alongside it. The moon has transformed into a critical waypoint for Earth's next leap, bridging resource potential, human infrastructure, and orbital innovation.